So I'm a professor here in Earth and Atmospheric Sciences. I'm actually a person with a training in atmospheric science, but I work with the big climate models, thinking about long-term climate change. And I personally put in some of the feedbacks between the physical climate system. And so in the Intergovernmental Panel on Climate Change, the IPCC world, I'm actually a working group 1 kind of person, okay? Everybody's in some working group. So I'm not really a person you would think who would be really interested in carbon dioxide removal, actually. But this report made me very interested in carbon dioxide removal, and I hope as part of this presentation I'll share with you why. So the slide that you see up here, hopefully, yes, is a slide that if you've seen me give a talk recently, you've seen a very similar slide, because it's actually something the IPCC gave to those of us who were lead authors on this report to try to disseminate the report out. And so if you see this kind of formatting or the IPCC logo in the side, it's actually a kind of an officially prepared slide that they want us to go out and present. These reports take thousands of hours of scientist time, and so they really represent a huge amount of work, and they want us to disseminate the information. So here's the official language of this particular special report. It is an IPCC special report on the impacts of global warming of 1.5 degrees above pre-industrial levels and related greenhouse gas pathways in the context of strengthening the global response to climate change, sustainable development, and eradication of poverty. It's really extremely broad. Normally the IPCC does not do this broad. It's really just focused on climate change. And so in this report, to some extent, we're supposed to solve all the world's problems in 100 pages, okay? It's really what we were trying to do in some sense. But I think it has two parts to it, and it really lays out the conflict between development and climate change. And we are developed here in a developing country here, we're the rich ones, and we got this way by emitting a lot of CO2, which has accumulated in the atmosphere. The developing country would like to have our lifestyle, okay? And most of the emissions in the future will be from developing countries. And sometimes I think people don't understand when we talk about very strict limits on warming, we could be heavily impacting people in developing countries. And so that's what this dichotomy really is, and it's put forward very clearly. So this is a figure that we wanted to put in our chapter but was pulled out for space sake. And it points out that although, as you're going to see in the numbers, climate change we have not done a very good job of addressing so far and cutting our CO2 emissions. We've actually been surprisingly successful at getting rid of extreme poverty. So this slide here, you're seeing 1820 to 2015, the increase in people. We're over 7 billion in the green. On the other hand, the number of people living in extreme poverty increased, but then has been decreasing, okay? Now, I'm not saying poverty is over, but we've been bringing people out of poverty, and we've been doing it by emitting CO2 up to this point. I mean, these things are related to each other. And so, there is the positive that we have been successful at limiting extreme poverty, okay? But that has been making also the climate change problem worse, too. So here we have the temperatures, global temperatures from 1960 up to present, and then you just extrapolate it, and you see we cross 1.5 at about 2040. And then we try to estimate kind of in an ideal world, what would you have to do to make it so that it didn't keep going up linearly, you just extrapolate. What has to happen to kind of stabilize global surface temperatures at those levels? Well, to understand that, the most important thing is to understand CO2 emissions, okay? And the CO2 emissions here from 1960 to present have been going up very steadily, okay? If we want to stop global warming at 1.5, we have to reverse the direction of the CO2 emission rate, growth rate. We have to cut CO2 instead of allow it to go up at a very steep rate. So we have to be at zero, maybe by 2055, maybe by 2040, it depends what it turns out the climate sensitivity is if we want to stay below a climate target like that. So this is the crux of the matter, is how do you change the momentum in the system in this way? So one of the things about this report is it was called for by specific countries, the Small Island Developing States, apparently in a very passionate appeal to the UNFCCC. And just saying, look, 2 degrees is too much. Can we at least look at 1.5? And the reason that, 2 degrees to some extent people argue is actually a political goal, or 1.5, but 2 degrees is actually the lowest level that the climate scientists, people like me but who run integrated assessment models, thought was really possible to reach, to keep the temperatures below at 2100. So that's kind of why 2 degrees was one of the benchmarks here that we were thinking of, is that in the other assessments done by the IPCC, we'd only consider 2 degrees, and they wanted us to consider 1.5. So one of the things they wanted us to do is to say, what's the difference between 2 and 1.5? You guys have already told us about 2. Tell us what could happen between 1.5 and 2. And this was pushing us scientists to actually take a look at small differences, like 0.5 degrees, right? Actually, Trump tweeted this, right? 0.5 degrees, who cares, right? But it made us take a look at what the difference is in the temperatures and whether it matters. And so there's actually a little bit of new research that came out because of this push from these countries to take a look at the small increments. And it turns out you can see the differences in statistically significantly in ways that people will experience, okay? So 0.5 may not sound like much, but people will experience something differently. I don't want to go in too much details. You guys probably know most of the big impacts from climate change. And it makes a difference in less extreme weather, in global mean sea level rise, and people who are exposed then to the sea level rise. Lower impacts on biodiversity, and smaller reductions in yields, and global population exposed to increased water shortages is actually 50% less with that really tiny increment. That's a big deal. Up to several hundred million fewer people exposed to climate-related risk and susceptibility to poverty. These sound like big deals here. Often in the IPCC, we like to show these kind of reasons for concern graphs. And so in the 1.5 report, there was a little bit more resolution of what happens between 1.5 and 2 than previously, and that's because some coral bleaching events occurred. So we had a few more events, and therefore we could get more statistical significance here in looking at the impacts here. But otherwise, these graphs are actually very similar to what was in the previous reports, but they only look up to 2 degrees. So I just want to focus back out on where we are kind of in the big picture, and just point out that, here's the global surface temperature, 1900 up to present, and then this red line is a business as usual line. So maybe we hit 5 degrees C at 2100. This is what's called a 2 degree line here that was in the last assessment report here. And the reason it's 2 degrees, although the mean looks lower, it's what we want is a 66% chance of being below 2 degrees, okay? Because we don't know anything for sure. We want to increase our likelihood. So this is considered a 2 degree scenario here. And so when you start looking at those same reasons for concern, they don't end at 2 degrees, okay? We don't fall off the planet at 2 degrees, that things just get worse. The higher the temperature, the worse things get. That's all the evidence that we have right now. And so, I'd like to say one of the conclusions from the 1.5 report is every 0.5 degrees matters, okay? And it just makes things harder for people to adapt to. It's more expensive, and it's harder on ecosystems. The other point I want to make here is that this is a business as usual, and this is a 2 degree scenario. And right here, where we are right now, these two scenarios have a huge difference in how much money people spent to mitigate. Okay, so they spend the money now, but you see the benefits in the climate, out here. Okay, and this is the intergenerational equity issue. It's just a really hard problem to get people motivated to spend money to save people later. Now, it was really interesting with the 1.5 report because all of a sudden you're talking about 22 years from now instead of the end of the century, and we can see the difference. And I think that's one of the reasons we got so much publicity is the short target. So the government politicians, they know how to talk to people. That, in the end, I was like, oh yeah, they know how to motivate people to really think about the problem in the short term. And you put a low climate target on there, and you get the scientists to point out that we can see that difference and make it soon. Then I think you get actually a little more attention. But that wasn't really new, right? So the journalists would ask me, wow, that's so new. And you're like, no, no, that's really similar to what we've been saying before. It's just with the low target, it makes it feel more new. And then, the other point to make that the climate justice people here at Cornell have made, for example, Dick Miller, Ravi Kemper, or Henry Shue way back when, is just that if we continue to eradicate poverty and people continue to get richer, mitigation, then you're forcing the poor today to mitigate for the rich tomorrow, okay? And so, the poor today are not going to see any benefits from mitigation, or very little. They're just going to suffer the impacts. But it's going to be the people in the future who hopefully will be richer, okay? So that's the other weird inequity. If we continue to eradicate poverty at the same rates, then we have this other issue we need to be thinking about is intergenerational equity, but rich versus poor in different generations also. It makes it really, really complicated, I think. So let's talk about what you have to do to reach 1.5 versus 2 degrees or some of the other projections. One of the things that we were really forced to do by the governments was to come up with scenarios, and the scientists come up with scenarios where we didn't overshoot 1.5 and come back down again, that we plateaued under 1.5. And there actually weren't any scenarios when we started that didn't overshoot and come back down. So people had to generate some scenarios like that, basically. So these are pretty hard to come by. They had to really tweak their models to get the scenarios to plateau at 1.5 and not overshoot and come back down. But if we want to limit warming to 1.5 and never overshoot, then the CO2 emissions have to fall in the next 12 years by 45%. Okay, and so this number, again, lots of people are talking about what has to happen by 2030. If you don't want to overshoot 1.5, by 2030 we have to be reducing emissions already. It's a really, that's a big difference. If we just shoot for 2 degrees, for example, we have to cut by 20%, so it's much gentler. To limit warming, we have to be net zero by 2050 for 1.5, but by 2075 for 2 degrees, okay? And we have to be net zero, right? We have to bring all CO2 emissions down. Instead of increasing every year, they have to go down. Now, one of the things in this report that we really tried to emphasize is all the positive benefits of limiting climate change to try to increase the odds of this occurring and of people implementing the climate policy. And a lot of the non-CO2 emissions that you would deliberately or accidentally a lot of the time reduce as part of climate change policy would have immediate health benefits to people. So there's a lot of things you can do that only help the people in the future, but a lot of those same things actually help you today. Okay, so let's think about what those are and really try to sell that package. And that's a lot of what we tried to do in this report: is look for things that it helps them and it's super important because of them, but it helps us too. Okay, and that was a big emphasis in this report. Now, limiting warming to 1.5, as I already said, was not something that we had scenarios already built for, because it's really hard in these integrated assessment models to get to 1.5. The lowest was 2. It requires changes at an unprecedented scale. Okay, you have to have deep emission cuts in all sectors. You have to use a range of technologies. We tried to set out a whole menu because, of course, every location is different. What's going to work one place won't work another. So we set up menus of all different things. But really, you got to do a lot of those. You can't just do 1 or 2. You have to do a lot of them. Really importantly, to keep it under 1.5, you have to have kind of radical behavior changes. That's what they had to play with their models and tweak. We right now, we have the choice to cut our emissions in half tomorrow, anytime we want, and that's, stop driving, stop flying, eat much lower, no food waste, right? Stop buying things. There's a lot we all could do very quickly to cut emissions. Just seems a little unlikely, let's just say that. I mean, so that's what would be required for this 1.5 report. And not just everybody in this room, but everybody on the planet would have to do that, right? So these are some of the things that are required to really keep it below 1.5. In addition, and especially if we can't get all that behavior change or can't get all these changes right away, we need increased investment in low carbon options. And, that includes the carbon dioxide removal technologies. So we have all these great new technologies in solar and wind, and it's cheaper than fossil fuels, all these really great things that make me think that really we can reach some of these low climate targets. But the energy sector may be the most important sector, but it is not the only sector we have. The industrial sector, transportation sectors, they also have to have similar innovations in technology to make it so that they can also transform. Now, and also, we have these technologies in the energy sector, but we have not yet transitioned, okay? But those technologies exist, so that's very positive. But we don't even have the technologies in some of the sectors. And we have to take carbon dioxide out of the atmosphere, and that's a really important result. And let me talk more about that. The current technologies we have for taking carbon dioxide out of the atmosphere have incredible implications for food security, ecosystems, and biodiversity. And this is where the problem lies here. So sometimes people say, oh, well, the Paris Agreement should take care of all this problem. And one should recognize that the Paris Agreement, the voluntary agreements that the countries said they would do, at the same time they said we want to keep global warming below 2 degrees, they said that we'll cut these emissions. Those emission cuts are actually consistent with about 3 degrees warming, okay? So they promised to do one thing, and then, right, their goal, and it's totally different. And that we have to start acting before 2030, right? So we have 12 years. People talk about that. Now it's 11. So. All right, so this is where you start seeing carbon dioxide removal really come out in this graph. So I'm just going to concentrate on the leftmost version here and the right one. And the other ones are in between. So here's our fossil fuel and industry emissions in gray. Then this brown is agriculture, forestry, and other land uses. Okay, and right now it emits CO2. But there's lots of clever things we could do way, way better. Reforesting, stop deforestation, reforesting, afforesting, soil carbon sequestration in agricultural soils. It just totally makes sense. We should do it. If we did that, then we could have a little bit of a sink then, instead of a source from those sectors. This particular scenario is the one where everybody has that behavior change I said, okay? So we could do this as long as all of us, stop driving and all those other things, okay? On the other hand, this scenario doesn't require such radical behavior change. It requires some behavior change. But you could see it takes maybe, 30 years or something to start having the really sharp downturn. So we stop building power plants based on coal and natural gas, and we just start putting in everything we can. We develop new technologies, right? This is what we could do here. But, this 20 or 30 years that it takes us to transition means we got to suck down that carbon that we emitted over that time period somehow if we want to go back down to 1.5. So this scenario overshoots a little bit and we go back down. And we can't just do it from agriculture, forestry, and land use, right? We have to have this yellow sucking down of the carbon. And you can see the scale. It's 20 billion tons of carbon per year, of CO2 per year. And right now we're emitting 40. So it's almost of the same order of the infrastructure that we right now have emitting CO2, cars, power plants, everything we do. We have to have that same infrastructure sequestering CO2 instead, okay? And we have to be, deploying it by 2030. Okay, whatever this technology is, we have to be deploying it by 2030 to get it sucked down here. Now, the technology that is used in the integrated assessment models right now is the bioenergy, carbon capture, and sequestration. Okay, so bioenergy, here at Cornell, what we're thinking of doing is growing willows and cutting them down, and then, putting them into little pellets and burning them in our plant instead. Okay, so that's bioenergy. So you're replacing fossil fuels with the bioenergy. And then you take the CO2 out of that, and you stuff it down into the ground, and it hopefully stays there and doesn't cause any earthquakes. Okay? So that's the idea of BECCS. And not only that, but you have to do this on a huge scale. Okay, that's what we're talking about here. And then you'd need CO2 pipelines instead of natural gas pipelines to the places. This is a lot here that we would have to do. And the models right now are assuming that BECCS is the most economical way to do this. But a lot of people have written papers just saying, this is crazy. The implications are enormous, that we don't even want to do this, right? I guess this is what motivated me to say, well, gosh, we should really be looking for smarter ways to be doing CDR than just BECCS. Okay, let's not use current technologies. Let's try to innovate a little better in the carbon dioxide removal space. So this is actually from the chapter 4 of the special report, and it talks about afforestation and reforestation. It's relatively cheap per ton, but you can only do maybe up to 3.5, they think, right? And remember, we need 20. And then soil carbon sequestration, mostly in agricultural soils or biochar. They estimate that those could do some, but it's not 20. Okay, so then you have to pull in these more expensive ones. And like I said, right now these models, very simple models, estimate that the BECCS is the cheapest and best one. But we've already talked about the food security. I mean, the food security implications, the water quality, the land, all those biodiversity implications of how much land there. On the other hand, there's a recent National Academies report from the US that lays out a research plan that really focuses on many of these other technologies, okay? So, and this is also, we at the Atkinson Center are also like, oh, well, we should be able to do better than this, okay? BECCS might be our only shot, but I just don't believe it. We need to be looking, we need to be investing. I think Aaron gave a talk yesterday about how much R&D money the federal government was putting into carbon dioxide removal in the US, and it's a pathetic number, okay? And it's such an important issue. So I mean, these kind of diagrams, when I was working on the 1.5 report, are the ones that got me really excited about trying to think about whether there's the potential for carbon dioxide removal and some more innovative technologies there. So there's a lot of articles talking about how terrible BECCS could be. I don't want to talk about it too much. I do want to say that the report really, as I mentioned before, really tried to look at how climate action and other goals, sustainable development goals, or sustainable development as a goal, can work as synergies, and where there's the potential for trade-offs, right? We would highlight those, but things to worry about, but try to look for the ones where they're both moving in the same direction. So I think that's mostly what I want to say here. It's in summary, we're already at 1 degree, and if we want to stay under 1.5, that's very aggressive. We need to adapt to the current level. We already have a lot of climate change that's occurred, and it's going to be hard to keep it to 1.5. So whatever level we're at, we're going to have to do more climate adaptation too. It's really ambitious to reach 1.5 or 2 degrees. We need to move to sustainable energy now. We have to have behavior change. We need to move to sustainable ag, and we're going to have to develop carbon dioxide removal technologies. And because the current ones that we have available, we might decide they have too much environmental or social impacts and decide we'd rather take 2 degrees versus 1.5 just because of those impacts, right? Those choices might be what we decide to make. So the report tries to identify the trade-offs, but really look at the synergies. And some people say that this, when I've given this talk before, that this is a very depressing talk, but actually I'm very excited about where we are right now. A few years ago, I just said, oh, we're going to 5. That's it. Nobody's doing anything. We're going to 5. But now there's all these technologies, and there's more political will to actually do something. The availability of solar and wind at very cheap levels is enormous. And you just think if we can have the same kind of revolution in other areas, in industrial emissions, transportation emissions, and in carbon dioxide removal, we really could get to some lower levels. And every 0.5 degrees matters. And so as low as we can get it, that's going to make a big difference. But we do want to watch and make sure that we're not harming the poor of today and how we're constructing this. I got a lot of emails from people who work in development specifically saying you are underestimating the impact of the mitigation efforts, that foreign climate change is bad, but those mitigation efforts are worse. There's a lot of debate there, and I think it's a valid debate of what how low can we keep it. And the other part is, we used to, for climate change, we used to only kind of be allowed, especially in the NGO, the environmental NGO community, to think about mitigation. All we should do is cut emissions. That's all we should do. And we weren't even allowed to talk about adaptation for a while because that's giving up. And now we have to talk about adaptation. But not only do we have to talk about adaptation, we have to talk about carbon dioxide removal. And again, that was like a no-no. Don't talk about that. Make those people cut emissions. But we're at the point where we got to cut emissions and do carbon dioxide removal, and if we want to hit any of the low carbon targets. So that's why I think this whole symposium here is really talking about a really important issue, and I think the justice issue of who did what and how to solve this problem is also something that we need to be thinking about with the carbon dioxide removal part of the question. Thank you.